Krishna Academy. So today I will be explaining how to derive the equation for resistance in series and resistance in parallel. And why I am explaining it in English, because there are a lot of students who are coming here for English speaking course, and suppose he is in class 11 or 12. So I am trying to explain them in Hindi as well as in English, so that they can be automatically practice the English speaking courses also. So there is nothing that you should have some special course for that. If you are speaking in English daily, then also the problem will be solved, isn't it? So now we will be practicing for deriving the equation for resistances in series, which is very important. Okay. So here suppose there is a voltage source or potential difference plus minus. Now the current I is going through this circuit. In the case of resistances in series, the same current that I have shown by I will be flowing through the whole circuit. Okay. Like here, if I here is here also, then I will be, but the potential drops will be different. Like in the case of resistance R1, the potential drop will be V1. Then in the case of R2, the potential drop will be V2, and similarly it goes on. And if it is Rn, then the potential drop will be Vn. So what can be written here? This V, okay, without V1 and V2, this V will be equal to what? This V will be equal to V1 plus V2 plus V3 dot plus Vn. Okay. Now we know that V is equal to what? Ri, that is resistance into current. Okay. So here what can be written? Here we can write it as Ri. And here not R. This will be R1, because this is the potential drop across the resistance R1. So this will be what? R1, and I will be same because the current is same everywhere. Okay. Now here what can be written? Here we can write similarly R2I, R3I dot plus RNI. Means it depends on the value of the resistance what is coming across it. So now what can be written? See, I is common both sides. So this I gets cancelled. So what is remaining? Here it remains R is equal to R1 plus R2 plus R3 dot plus Rn. So if the values are like 1 ohm, 2 ohm, 3 ohm, then 1, 2 and 3, what is it? 6 ohm. So that is the equivalent resistance. So what will be the equivalent circuit? Here we can write like this. And this is the actual R that we have written the formula for. And what will it be? This will be equal to R1 plus R2 plus R3 plus dot plus Rn. That's all. Okay. So this was for resistance in series. Now I will be deriving for parallel. Now one of my students is making the video, so I am not sure how the quality is, or his hands are shaking. So I will check it up and then start the next video. Okay. So you can stop the video.